Welcome. Today we're going to be talking about a transport layer protocol, TCP, or Transmission Control Protocol. Whether you're streaming your favorite TV show or sending an email, TCP plays a huge role in how this information is sent. But what is TCP? To understand TCP, let's first look at where it lives in the network structure. The transport layer. This layer is crucial as it acts as a middleman between the applications you use and your network, ensuring data is both sent and received correctly. Here's an example. Think of TCP as a super efficient mailman who not only delivers you your mail, but ensures that it gets to the right person, arrives completely intact, and arrives in order. That's what a transport layer protocol does in a broad sense. It manages the data exchange between your device and all sorts of other devices over the internet. Millions of people use TCP every day without even realizing it. Of course, we can't talk about TCP without mentioning its little brother, UDP, another transport layer protocol. To compare these two, I've come up with a simple analogy. UDP is like a sprinter. It's all about speed. It sends data quickly and doesn't worry much about errors or data arriving out of order. Those things take time and overhead. TCP, on the other hand, is more like a marathon runner, patient and calculated. It manages flow, mitigates congestion, and most importantly, it checks that all the data arrives without errors and in the right sequence. Okay, with that out of the way, let's break down TCP's key concepts, which help ensure reliable and efficient communication. For reference, here's a diagram of a TCP packet. As you can see here, each piece of data has what's called a sequence number. This number helps the device receiving the packet arrange the packets in the correct order, even if they arrive in the wrong order. Next is the acknowledgement number. When packets each reach their destination, the receiving device sends what's called an acknowledgement. If the sender doesn't receive this acknowledgement, it will resend the packet. This is a big part of what ensures TCP's reliability. While sequence and acknowledgement numbers are important, there are also two key mechanisms beyond the packet which enable TCP to perform so well. The first is congestion control. TCP has several mechanisms in place, as you can see shown on the graph above, to control network traffic and avoid congestion. It is effectively the rate of data transmitted based on network conditions. Finally, we have flow control. TCP uses flow control to prevent overwhelming the receiver. Think of it like adjusting a faucet to prevent too much water from leaking through. And with that, TCP ensures your data not only gets to its destination, but also in perfect order and condition. Next time you check out a web page or stream a video, remember, that's TCP.